In this video we're going to talk about static charge and how we can use static charge from use in the real world, talking a bit about current as well, but the main thing we're really going to get onto, which is a high level skill, is talking about how static charge can be used to explain some phenomena in the world around us, like lightning and balloons sticking to walls and ideas such as that. Right, so we need to state the definition of electric current and explain the differences between AC and DC. Okay, so remember, electric current, okay, is the flow of charge. Normally it's an electron. We talk about in physics, but it's the flow of a charged particle, normally an electron. AC and DC, or alternating current, means it can be positive and then negative. It has to be positive and negative. DC current is just positive or negative. So let's have an example, look at a couple of examples of those. Okay, so we go right to the end of this. There we go. Okay, so you got the idea of AC and DC. Direct current is when current flows in one direction only. AC, remember, it flows in both directions. It says over here current is a flow of electrons. Charge, current, time are all linked, and there's the equation that links everything like that. Okay, next. Okay, so we've got the structure of the atom, including charges and masses, and we also really need to talk about charges and masses there. Okay, we also really need to talk about how objects can become charged using friction, and then what happens when you have like charges and opposite charges near each other. So let's talk about that. So if we go back to that part of my document, just over here, okay, you've got a picture of the structure of the atom. So remember, the atom has protons and neutrons in the middle. Okay, it's got protons and neutrons in the middle, over here in the nucleus. Protons are positive, the p's go together. Neutrons are neutral, the newts go together. Okay, and electrons are therefore negative. So you can see that protons have a mass of 1, neutrons have a mass of 1, electrons have no mass. They actually have a very, very, very small mass, but we say it's negligible. Protons are positive, p's going together. Neutrons are neutral, newts going together, and electrons have a charge of -1. Also said that we wanted to know how objects become charged. So objects become charged using friction. Friction causes electrons to transfer, to move. And remember, electrons have this negative charge. So if they move, sorry, is that right? Okay, so if they move from one place to another, they'll end up with charge moving. So electrons move from one material to another. The material that loses electrons becomes positive. It gains electrons, it becomes negative. Okay, so in other words, if I put next to each other a positive and a positive, they will go apart. So they literally move apart from each other. If I have a negative negative, again they'll move apart, they'll repel. Okay? However, if I have a positive and negative, they attract. Okay? Electrons can move easily through conductors. So if an object is charged, we can earth it by attaching a conductor to it. That means a charge will therefore flow to ground. The next point, if I remember correctly, is all about the dangers of charge. Remember, earthing gets around some of those dangers. Yep, so describe the dangers that could occur with electrostatic charge and explain how they can be overcome. So the main way of overcoming the dangers is by using earthing. Okay, so that's what this bit was about over here. So electrons can move easily through conductors, and an object is charged, it can be discharged easily by putting in a conductor between the object and earth. The charge and first earth. So that's how we get around the dangers. But what are the dangers themselves? Okay, the main dangers, okay, are over here. The main danger is with fueling. Okay, because remember, fuel is highly flammable. So if electrostatic builds up, anything, an aircraft tanker or a tanker with fuel, or even a car, okay, as the fuel enters the tank, static can build up, and this can cause spark, which could ignite the fuel. You get around this by earthing the object. Okay, so earthing, a bit more about it is over here. So an object can be earthed by connecting it to the earth with a metal wire or other conductor. If the potential difference, in other words the voltage, is very large, a spark may jump between the gap. This can be dangerous as it can cause an explosion like at a petrol station. Excellent. So then B, the dangers. So now we need to discover for an AMA star, we need to describe and explain the use of electrostatic charge in paint and insecticide sprayers. And then for an A star, we really need to get into everyday things like shocks from objects, lightning, and sticking the balloon to a wall. Sticking the charged balloon to a wall is the toughest one of the bunch there. So let's go through these one by one. So if I have a paint sprayer, I'm going to draw one of these I think as well to make it a bit easier. Okay, so if I have a paint sprayer, like so, it's got paint coming out of it. All the little flecks of paint that's spraying out of there can end up with a positive charge or a negative charge, end up with the same charge. Let's say they're all positive. You can have them easy. Every paint is positively charged, therefore they all repel each other. That repulsion leads to an even spread. What that means is that you end up with a nice coat, okay, a nice coat of paint. But if you're spray painting an object like a metal sheet and you give that sheet a negative charge, what's actually going to happen is a negative charge, right? What's actually going to happen is the paint will wrap around the back so that little paint is wasted. Okay, I've got that over here. Okay, so remember, like charge is attracted, like charge is repelled, unlike charge is attracted. The spray gun is positively charged, which causes every paint particle to become positive charge. Like charge is repelled, the paint particles spread out. The object is painted, giving a negative charge that attracts the paint particles. The advantage is that less paint is wasted. The object receives an even coat. And also you can cover awkward shadows. Okay, so if there's a curved surface that you're painting, the paint will get into those curved surfaces because of the attraction. Insecticide sprays use exactly that same idea. Okay, sometimes I ask about smoke precipitators, so it might be worth pausing the video and reading through the bit on smoke precipitators to scroll down slightly in case you need that. Okay, the final thing that it said about was some everyday examples like car shocks and crackling clothing and balloon sticking to walls. So let's go through those. I'll go through balloon sticking to walls last because that is the trickiest. So charging a comb, when you run it through your hair, transfer of electrons, one becomes positive charge, one becomes negative charge. Okay, you can use that comb to then pick up pieces of paper by the process of induction. I will go through induction when I go through balloons sticking to walls. So hold fire on that one. Lightning, the same idea. So clouds rub together, one becomes charged, and therefore a large amount of charge builds up. Earth is earth, zero charge, and therefore a spark can happen between the two because there's a large potential difference. When you rub clothing over yourself, okay, again there's a transfer of electrons leading to statically building up, and that can be seen as sparks. And car shocks, okay, is when you rub against a car seat, sometimes that friction causes a transfer of electrons. So when you touch a metal strip on a door, sometimes you feel a very small electric shock. That's just my ring bashing against the table there. Right, balloons sticking to walls. This bit's tougher. I might actually add a bit of space in this diagram. Actually no, I think I'll draw it over here. So here's a wall, and it has positive and negative charges. Here's my balloon, and it's just negatively charged. So that's become negatively charged by us rubbing the balloon against our hair. Okay, so that's become more negatively charged. It's gained electrons, it's become negative. I move that balloon now towards the wall. These negatives will repel the negatives in the wall. So they'll go over here. That means I've induced a positive charge on this side of the wall. That attracts the balloon towards it, and therefore they stick together, meaning the balloon sticks to the wall. So when you rub a balloon against your hair, or even clothes, okay, electrons transfer to the balloon, making it negatively charged. The balloon will now stick to a wall even though the wall has no overall charge, which is what we were saying. This is because the charges in the surface of the wall can move a little, so those negatives move. Moving negative charges away from the surface as they repel the negative balloon. This leaves a positive charge on the wall, which attracts a negative balloon. This method of using a charge object to force a charge in an uncharged object is induction. So that's where we force a charge in an object. And that is everything you need to know about charge.